Good afternoon, everyone. I think we're going to start this last panel event of the day for SERA. I want to say welcome. My name's Jo Blackman. I'm on the exec of SERA. I'm also SERA's delegate to conference as well this year. First of all, well done, because you've made it towards the end of the Fringe programme, and really grateful for your dedication coming to this, and appreciate it's been a long couple of days for everyone. But I'm really pleased to be chairing this panel this afternoon. We are going to be talking about carbon capture storage, which is obviously a real key plank of the government's climate policy and energy policy. We've been hearing references to it already this week from Rachel Reeves and Keir Starmer, and I think we're very likely to be hearing about it from Ed Miliband tomorrow. There's big numbers involved that we've also heard about, pledges of over 20 billion, as well as prospect potentially of jobs and carbon emission savings as well. But there is some scepticism as well that we're going to be hearing more about this afternoon as well, and some concerns about how some of those claims and ambitions stack up. But I think it's really important we have this opportunity to scrutinise some of the plans on it and really unpick it and see whether this is see how we can help work with government and the Labour Party to strengthen that. Okay, that sounds better. Thank you. I think we're all getting a bit hoarse as well at this stage, so it's any help projecting is gratefully received. So I'm going to ask each of the panel to talk to us about what role they see for CCS in delivering the government's climate ambitions, and then we'll maybe put some supplementary questions before opening it to the audience for questions as well. I'm just going to start on my furthest left with Simon Oldridge, who is a really effective climate communicator, which I think sounds a bit fluffy, but I think when you hear from him, you'll understand what I mean. And Simon's done various work with organisations campaigning, including 0 Hour and MP Watch. I'll hand over to you, Simon.
Thank you very much. And hello, everyone. So we're just doing, how many minutes do you want us to do?
Sort of 3 to 5.
Okay, so carbon capture, let's not be, just my tech support is going to help me get this online, because I have a few graphics to explain the points I'm going to make. But let's not be ideological about this. We're facing a really serious crisis, and we need to consider all options. But we need to consider them by looking at the evidence and making an assessment of what we think will best work before we spend lots of money and time. So the first thing about carbon capture is it's such an amorphous term. Lots of people are confused by it. What does it actually mean? It's not the main thing that is happening in each of these processes. It's a sort of subsidiary waste capture process. So we need to, first of all, look at the various types of carbon capture. And the Climate Change Committee has projected how much they think this country will spend, public and private, on carbon capture to 2050. And you can see here the relative amounts that will be spent on different areas. So on the left, you've got new power generation. So that's gas power stations, building new gas power stations. And then you've got biomass, burning trees and waste wood at Drax, and then various other things. Now at the end there, you've got industrial emissions. So when we hear carbon capture being discussed, it's normally through the frame of capturing existing emissions from industry. And that's a perfectly sensible thing to try and do. Why not? But that's only around 6% of the total spending. Now, all of this adds up to 408 billion. Now, we've all heard the 22 billion, but that's only just what's announced in the near term. This is the pathway that the government's on. It's spending 408 billion on carbon capture. And those bars there, so you've got 136 billion on building new gas power stations with carbon capture, and on extending the operation of Drax Power Station. Now, I'm going to focus on those first two bars there. I'm not really arguing about industrial carbon capture. We probably need to do that. We almost certainly need to do it. But for the first bar, for building new gas power stations, we are getting our gas, around a quarter of our gas is shipped in now as tankered LNG, because North Sea gas is on the decline and it's projected to have almost gone by 2050. A quarter of what we burn in the UK is shipped in. Now, the US, since the fracking boom, is our main supplier. Around 80% comes from the US. The problem is natural gas is methane, and methane's a really potent warming gas. It's 84 times worse than CO2, and it's leaking all the way along that vast supply chain. And the upshot is that only a third, so we're building these new gas power stations here, only a third of the emissions happen at the chimney stack of the overall life cycle of using this, of burning gas. 2/3 happen upstream, up here. Now, carbon capture is not helping with this lot. It's only helping with the 1/3. So even if the promises of carbon capture are delivered, and there are some big questions on that, 2/3 of those emissions are still going to go up into the atmosphere. And this is new science. Now, Ed Miliband was quite right to look at carbon capture and to push ahead with it in 2009. But we know a lot more now, and we need to be responding to these new facts. And the facts suggest that if we proceed and build gas power stations, and burning trees at Drax is a similar argument to this, we are going to be causing roughly the same emissions as burning coal when you add in the whole life cycle. So that's probably enough for now. So I'll pass on. Thank you.
Thanks, Simon. That was really helpful. If it's okay, Olivia, I'm going to hand over to you to get your perspective. Olivia, Powis is Chief Executive of the Carbon Capture Storage Association, and can maybe give her perspective on these issues too.
Thank you. So Olivia Powis, Chief Executive of the Carbon Capture and Storage Association. We are the trade association that promotes the commercial deployment of carbon capture, utilisation and storage. We have 120 members across the value chain, and we are technology agnostic in terms of it doesn't matter, we will represent carbon capture on gas CCGTs, hydrogen to power industrial processes, as well as greenhouse gas removals, and also the supply chain that will have to supply those. So we, in terms of the whole scope of carbon capture, it is all within our remit, as long as it's engineered capture. So engineered removals, BECCS and DACS, so bioenergy with carbon capture and storage, and direct air capture with carbon capture and storage. So, I think the pretext of this is that this is an essential tool to decarbonise our industries, and that's been recognised by a number of independent scientists and bodies over many years. The IPCC has said that it's an essential tool to get to net zero. The Committee on Climate Change have also said the same and have modelled this in their scenarios, and the extent to which we'll need it to reach net zero. So in terms of the acceptance of this technology, and that we need it alongside deploying all our other routes to reaching net zero, is something that we will always just point to independent experts and say that this is something that we need to deploy. It is commonly recognised, I think, as the solution that is required for many hard-to-abate sectors. There are industries such as the cement industry, fertiliser, chemicals, energy from waste, that will find it extremely hard or impossible to decarbonise in other ways. So carbon capture and storage offers them that route to decarbonise and for us to meet net zero. It also plays a critical role in terms of decarbonising energy and enabling more renewables onto the system by providing that flexible, dispatchable energy that we need to maintain a stable energy system and to balance our grid. So in that sense, there are a number of different technologies that will need to deploy CCUS. And so our role has been in terms of making sure that how can we make this happen. It's not a new industry. It's an industry that has successfully been deploying and working globally. It is new in the UK. These are the first projects that in the last year have taken final investment decision, and they will be the first ones in the UK. But we have been In Norway, they've been successfully capturing and storing CO2 for over 20 years. There are other projects globally. And so it's not a new technology, but it is in terms of how we're deploying it in the UK and the CCUS clusters. I think it has a critical role. It is never portrayed as a silver bullet. It's not something that should be deployed instead of lots of other routes to decarbonisation. It sits alongside those. But it absolutely is essential, and the sooner we can make progress in terms of deploying the industry and enabling the industries that produce the products that we need and use every day and will continue to, then it's absolutely essential in terms of helping us to get to net zero.
Thank you, Olivia, for that perspective. I'm going to go next to Josie Murdoch from Ember. Ember's a think tank, and Josie's looked in detail in some of this area, so I'm looking forward to hearing her views too.
Thanks. Hi, everyone. Ember is a global energy think tank, and our work to date on carbon capture has focused on BECCS, so bioenergy with carbon capture and storage, and specifically deploying carbon capture on biomass power stations in the UK. And Simon's already touched on some of these issues, but it's important to note that there were already a number of really significant challenges with biomass power generation that would be locked in if carbon capture is added to those plants. So the biggest biomass power station, Drax, they currently receive over £2 million in subsidies per day, so it's around 800 million annually. They import 99% of their feedstock. And there are sustainability concerns as well with their wood sourcing, coming from old growth forests in North America and Europe. So if CCS was added to their plant, then it would be locking all of those issues in the near term and in the long term potentially as well. It's then really important to note that all of the BECCS projects that are in the UK pipeline are delayed and not yet capturing any carbon, which means that we don't know how much it will actually cost to capture carbon when they have been deployed. We do know that project developers are seeking additional subsidies on top of what they're already receiving for power generation, so on top of that £2 million per day. So the cost is only going to go up. And so I think it's also really important to note that there are other ways to reduce emissions in the UK economy that are already possible and cost effective and will deliver other benefits as well. That really should be the focus of the government in the near term. So that includes deploying more renewables to bring down the cost of power, increasing electrification, so deploying more heat pumps, and increasing the uptake of electric vehicles, increasing industrial electrification. And these will actually all bring additional benefits as well to the UK, so lower bills, improved energy security. We won't be importing all of this feedstock from North America and Europe, and also job creation and increased economic competitiveness as well. So so our kind of key message here is really focus in the near term on clean power and electrification, and wait until CCS has been proven at scale before investing a lot of money into it. Thanks.
Thanks, Josie. I'm going to bring in Jennifer Cronin now, who is an academic from UCL and has also looked at these issues from a kind of wider systems perspective as well. It'd be great to get your thoughts.
Thanks. Yeah, I think broadly I agree with elements of what everyone said so far.
Oh, do you want to speak? Yeah, maybe.
Put this over. I can move it. Is that better? You see if I pick it up. Thanks. So I work at the UCL Institute for Sustainable Resources, and along with colleagues there, and also at the Energy Institute next door, we look at kind of a medium to long-term pathways or scenarios for how to achieve our goals within the constraints that we have. So we looking across technologies, across sectors, trying to look at things kind of in the whole. So the question is, what role does CCS have in delivering the government's sort of climate ambitions? And then if I sort of split that up into two parts in the first instance. So first instance is the clean power by 2030 target. And I point to the work here of particularly Professor Jim Watson and Oliver Broad. And what they've done is study specifically kind of least cost pathways. So using some models to look at what technologies we have, what energy demands we have, what the available options are, what's the kind of cheapest way to get from the system that we have now to this clean power by 2030 target. And that research suggests that actually kind of probably only small amounts of CCS are probably needed for that target. So in the next few years, 2030 is rapidly approaching already, but some part, but not huge amounts of CCS are probably needed. And how much and what kind depends on a number of other factors about what you do with the power system. So how smart the power system is, how much hydrogen you're using for the flexibility aspect, which Olivia, you mentioned as well, and also how much long duration energy storage, so big battery banks and other options that you're installing. So kind of how much you need really is affected by these other technology and therefore policy choices. And probably sort of one unit, putting CCS on one of the DRAX units would probably be enough for that, according to this analysis. But no other sort of big CCS power plants. But then using CCS on some of that hydrogen production would probably be needed as well. So that's the kind of the power picture in the very short term, as far as we see it from our analysis. The second is the longer term picture of our net zero by 2050 target. And here a range of studies, including those by my institute, conclude that CCS is probably very much needed to play a critical role in that, for us to meet our carbon budgets and get to that net zero greenhouse gas emissions by 2050 target. And we're talking quite a big scale up. So I think the Climate Change Committee says something like 70 to 180 million tonnes of CO2 being captured. And for reference, that's more than is currently deployed in the world. So that's just in the UK, more than deployed in the world. So we're talking quite a big scale up by sort of 2050. And of course, that's not all going to happen all at once at the end. That needs to be brought in sort of bit by bit. So what we do now, of course, affects then round by round what's happening over the next few decades. A couple of people have mentioned that not all types of CCS are equal and the same, so it's really important to think about exactly what we're talking about here. And the role, and what we're seeing is that, yes, have a look in the power sector. Some CCS in the power sector is probably needed. But also really important to be looking outside the power sector, probably more important. So we'll be needing to fit CCS to some industrial processes that are really hard to decarbonise. So cement production, for example, really hard to just prevent the production of CO2 during that from the chemical processes. And then the second is to, if we want to reach net zero, we have to draw down carbon from the atmosphere. We have to be taking out more than we're putting in. And so we need negative emissions, and that's where CCS has a really big part to play as well. So that's to balance remaining emissions from sectors like aviation and agriculture that are really hard to decarbonise in other ways. Some of that could also be done through land-based methods, which I can maybe speak to a bit in a subsequent question if there's time. But our kind of modelling at the moment suggests that technological engineered solutions, so CCS probably has a pretty important part to play in that. So our view is that there are technical challenges clearly with CCS. There are economic challenges, there are policy and regulation challenges. And there's a big chance that if we sort of bank on it too much, then maybe that's seen as a kind of reason to mitigate less. So that's always a risk that it delays other action. And then if it doesn't work out, it would have been better to mitigate more in the near, always with hindsight. We will have had hindsight, if you see what I mean. But I think it being hard doesn't necessarily mean it's the same as a false solution. I think that's a bit of a false dichotomy. It's not a binary choice between a silver bullet or a false solution. There are things in between. So our view is that it should be tested as it is at the moment with this round that's been announced, and then should be scaled and should be governed really carefully. So things like putting measures in place to maximise technological learning, that could be done, and really being really careful around monitoring, verification, reporting. And then there are questions around biomass, which I can speak to in another moment. But importantly, if we do decide against CCS or particular types of it, then we need to think really carefully about what we're going to do instead, because there are those really tricky kind of knuckle issues with process emissions in particular, a bit around flexibility in the power system, and lots around negative emissions. If we don't have CCS, we have to think about how we achieve those. Can think about that as well later.
Thank you, Jen. So I'm going to move now to Dr. Scott Arthur, who is the MP for Edinburgh South West and has a background in academia and engineering as well. And it'd be really great to get your reflection on maybe what you've heard and your perspective on Labour's approach on this.
So thank you, and I will start by reflecting on academia a little bit. So I was elected unexpectedly last year, and one of the things I found quite quickly is as an MP, you don't give lectures, because we used to be an academic, you don't give lectures anymore, you give speeches. And the big difference between a lecture and a speech is you get to use PowerPoint when you're doing a lecture. So I really envy Simon for bringing his PowerPoint along today, because the last 15 months have been lost without my PowerPoint slides, I have to say. So I think maybe 5 years ago, if I was talking about carbon capture and storage, I would have been quite sceptical about it, I think, because I think in a lot of ways it was about avoiding making some of those difficult decisions that we keep on talking about. And as part of my role as an MP last year, I think it was, I visited North British Distillery, which is my constituency. They make massive quantities of grain alcohol, which then gets used in blended whisky. And while I was on the plant, they've got a facility to capture CO2 from their processes, and they tanker it up, and then it gets moved off site and it gets used for something else in some other industry. For a millisecond, I thought, well, it could get used to make soda water for the whisky, which is, there's something great there. But then as a Scotsman, I wouldn't put soda in my whisky. So, but maybe there is some other use for it. But seeing the facilities they had on site for capturing that CO2, tankering it, then moving it somewhere else, it did get me thinking about, I mean, what is the efficiency in this process and what energy is involved in actually just doing that. So I do think that in the transition, we do have to be willing to make those difficult decisions, if I can put it that way. And we do have to think about change as well. You still allowed to say change at Labour Party conferences? I don't know.
Renew.
Renew. We do have to think about renewal. And you know, and I think Jennifer mentioned the aviation sector, and maybe this is a small example of maybe how we do have to change. It was just in a meeting we were talking about the aviation sector and the real power and the real place that it does have in growing our economy. So I do accept that. But they were speaking about the freight going through Heathrow. Two of the biggest freight items, either weight or value, I think one of the biggest ones for value is whisky. So it's not a time-critical export, unless you're really disorganised and you've left everything to last minute. And it's a really heavy export. So why are we exporting that by air? It doesn't seem right. And one of the biggest, I found out through a lunch meeting today with Bentley, the motor car people, believe it or not, one of the biggest exports by weight from Heathrow is cars. Cars are getting exported in aeroplanes to overseas, which again is absolutely incredible. So we do have to think about change as well. We do have to change what we're doing, reduce our emissions. And I think as Olivia put it, maybe for those harder to abate sources, the stuff we all know and love as a civil engineering academic actually, cement production, maybe there's the role for CCS to play there. I think we also have to think about how we reduce and become more efficient about how we operate our economy. And there is this torturous point about CCS. I've got a regular casework email that comes in who keeps on reminding me that the UK is a leader for a reason in CCS. It's because everybody else thinks it's a bad idea and we're one of the few countries that are doing it. But I'm sure I might be corrected on that. But there is a question there about why are we the leaders? It's good to be a leader, but is that for a good reason? And hopefully it is. Or is it because everybody else has discounted it? But above all else, I'm here to listen and learn, so thank you.
Thank you, Scott, for that. I really appreciate your openness and honesty tonight as well. And I think it's precisely because it is a relatively new technology and we are trying to be leaders in it that we really need to have debates like we're having this evening. I wanted to maybe go to Simon, because we've heard some of our speakers talk about how maybe it's needed for hard to abate sectors, but I know some of the work you've been doing with other organisations is around issues with the cluster model, that they are built around effectively often new gas-powered fire stations with CCS added on. and how that might bake in then reliance on fossil fuels. Maybe I've just stolen your answer in my question, but it would be great if you could maybe talk about that.
I think it's really important to get more into the different types of CCS, and to be clear that when the government talks about CCS, a lot of that money is going to expand the fossil fuel sector, which most people don't know about when they hear about CCS. Now, it's interesting, Jennifer, that you mentioned the UCL model about working out the least cost pathway to net zero, because I've been in touch with a professor there who's involved in writing that model. And we may not be talking about the same one, but the government essentially use a model which helps them work out the cheapest way to get to net zero. Now, the problem is that model this is where we go back to the problem that our climate legislation is outdated. The model works strictly to our UK climate laws, which say that we only need to manage the emissions that happen within our territorial boundaries, and we ignore emissions that we cause overseas through the supply chains. And now I think we all probably understand that if you buy something, buy a piece of clothing that's made in a sweatshop overseas, we take responsibility for that and we try not to do it. But the way our laws are set up is that we can build a new gas power station here that will be fed, because we haven't got any extra gas, we're already importing it. It'll be fed by LNG imports from the US, but we're ignoring all those supply chain impacts. So this is how this is a little explainer of how this model works, which essentially is working to the law, but the law's outdated. So here's the carbon footprint, and this comes from data from a well-known study that was released last year. So burning the gas is just a part of it. Those are all the upstream emissions from the methane leaks. It's worse than the burning. Now, the government's model ignores those because they don't happen within the UK boundaries. And then we say, okay, 90% of what's burnt will be captured. So the government's view and the model's view is that, great, these power stations, they're going to have a tiny carbon footprint. That's great news, isn't it? But we can't ignore those emissions that happen upstream. If we build these new factories, we're locking in those emissions. We're enabling Trump to sell his gas. And when you take a full life cycle picture of these emissions, which, I think you can see from a sort of common sense perspective that we should, the picture's 17 times worse than what the government says it is. But they're not looking at it like that because they are working they're doing their job. They're working to the laws. Now, our climate laws were set in 2008. And we led the world then, but they're really outdated now. They were set before we realized how serious the crisis was. They were set before anyone could see any of the impacts, and we were still debating it. They were set before the IPCC's 2018 report that told us 1.5 degrees was actually really bad news. Previously, everyone thought 2 degrees would be okay. That's when these laws come from, and we're still making investment decisions on that basis. Let's look at carbon capture for hard to abate industrial uses, but we've got to update our thinking on this because this is a huge amount of money we're going to be spending, and it's going to displace spending on other things that work. And one of the things that's really important is that there was a meta study a couple of years ago, a study of all the studies on renewables, on 100% renewable energy systems. And it concluded that there's a really strong agreement from independent studies all around the world that renewables can provide for all of our energy needs. And we don't need new carbon capture. I think there'll be some, industrial capture on the side, but for our energy system, we don't need it. And the reason it's happening is because fossil fuels the companies are really powerful in the UK. The reason that we've got carbon capture in the UK, and they have in Netherlands and a few other countries, is it's the countries with the gas, and where the fossil fuel lobbies are powerful. So, and just to conclude, I work with a lot of independent academics who are desperately warning the government that we're going down the wrong route here. A huge list of them, with IPCC authors, wrote to Ed Miliband urging him to reconsider. And put this out to proper consultation. And then there was a letter written by pro-carbon capture scientists, and it was in the Times, and they didn't publish the letter, and I thought that's strange. And we managed to get a copy of it, and we found that half of the very small number of signatures were people who worked in the fossil fuel industry and carbon capture industry. So there's a lot of power of organisations trying to cling on to what they've got. But we've got to stop, and because if we do this, we're locking in a really dangerous pathway, and we're missing the opportunity to spend that money on like insulating our homes, and restoring nature and things that are proven to work and that will deliver benefits for ordinary people, rather than spending a lot of money on stuff on these big offshore projects that don't employ that many people, where the money is going to be going offshore and barely taxed, because we still give 84% tax rebate to oil and gas companies for oil and gas, which is crazy, isn't it? It was 91% under the Conservatives. Rachel Reeves has lowered it to 84%. It should be zero. There shouldn't be any financial incentive for new oil and gas, and we should be directing all of that into the stuff that works.
Thanks, Simon. Some really interesting, no doubt provocative. I'm sure not everyone on the audience agrees, but really interesting. And Josie, I just wanted to ask you, I'm often hearing in fringes this week about energy costs and bill costs and how that's really critical to tackling the threat of reform, to show that we can bring bills down, help cost of living, and resolve, and help the transition to cleaner energy as well. I'd be interested to hear your reflections on how that fits with CCS and what the impact on bills might be, and what's the cheapest way to do this for consumers.
Yeah, so at the moment, biomass generation adds around £10 to our energy bills every year. So everyone in this room, that's £10 added. And as I said earlier, we know that these project developers will be seeking additional subsidies for adding carbon capture. So that is an increased cost to energy bills in the future. I think really crucially, we need to bring down the price of energy bills by bringing down the price of power in the near term, and that's what's going to deliver benefits to households and also industry. We know that the price of power falls in hours with higher shares of renewables, so we just need to build more renewables and increase access to renewables around the country, and reduce the share of gas in as many hours as we can going forward. And also increase storage as well, so that we can be accessing that cheap, clean power round the clock. And then that's going to enable the electrification that we've been talking about. So electrification of households, household heating, household transport, and also these industrial processes. We do know that you can electrify a lot of industrial processes already. So you can electrify steel making. We were talking about a new development in cement making, which I don't know too much about. You told me about that, but that would be amazing if we could. So I completely agree with the idea that having CCS on hard to abate sectors is kind of the best use case for it and the only use case for it. But also we can be supporting electrification of industrial processes in the near term as well. Sorry, I kind of deviated away from the energy bills point, but yeah.
Thanks, Josie. Olivia, I might come to you if that's all right. We've heard about the government's commitments in terms of how much they're planning to spend on this, but there's also some big risks that it sounds like they might also be underwriting in terms of some of the new projects as well. It'd be interesting to get your take. I think when we had a very similar event last year, you talked about in an ideal world, some of this would be able to be work without government financing, without subsidies. So it'd be good to get your thoughts on what the money looks like at the moment, and is it enough, and will it need more, and will it need to come from government or taxpayers?
Yeah, thank you. I mean, I'll come back to some of the points that have been raised. I think you've said, why is the UK leading on this? I mean, I think there are 50 operational projects worldwide, 600 in development, and these are all over globally. So it's the US, Canada, Singapore, Malaysia, Middle East, Australia, China, a huge amount of development, and across Europe now. So it is not just focused in one particular area. And there is arguably it's increasing much faster in some of those areas than it is here. And then why here? We have storage potential, and when you talked about the Netherlands, it's the countries that have progressed faster is because they've got the geological storage potential. So which is also where the oil and gas has come from. So there is an obvious link there. But that's true, and the UK has got a third of Europe's potential geological storage. Norway's got roughly another third, and the EU states combined have got another third. So we have this natural asset, and that's what and far more potential storage than we need for our domestic emissions. So that's part of what's driven the UK to develop in this, but we've also got an awful lot of industrial emissions. So we've got to deal with those. So those two drivers are looking at why the UK, and we've also got the expertise in the subsurface. So we understand the subsurface, we've got the skills, the jobs, the supply chain, and these are all reasons why it makes a compelling case for the UK. And it's why lots of countries in Europe that are also looking at their domestic emissions will consider where they store that CO2, because they have also got to find a solution for their industrial emissions. And so whether that's storing in other areas in mainland Europe, or whether that's cross-border to the UK, these are options that they're looking at. So these are just challenges that everyone is facing if we're going to decarbonise our industries, and we've got to look at where to do that. In terms of independence, I mean, I think other than just going over what I said right at the beginning, this isn't, there are, it is out there in terms of the IPPC, the IEA, the Climate Change Committee. These are independent bodies with independent scientists that feed into the process, all of which say CCS is essential. So there will always be people who will argue against that, but these are the bodies that have got systems and processes and checks in place to make sure that they are that the models and that the scenarios that they're putting forward are credible. And so, to keep going back over that is not really a sort of helpful way forward. It's just, these are, if we don't trust those bodies, that's a different question, I think, but those bodies have all said that this is an essential way forward. And your point on clusters, I mean, I think the decisions that we had last week in terms of the HyNet cluster, which is where we are now, the first two projects that will be connecting to that are energy from waste and cement plants. It's not built around a gas power station. And that's because they're the industries that are here, and they will connect to those clusters. So it is, the government has been clear about how and why they want to develop carbon capture, and it is industrial decarbonisation that is the driving factor there. There is now a Clean Power 2030 target, and of course that also comes into it. And in terms of the independent advice, the NESO was the body that the government set up and tasked with recommending how we reach that 2030 target. And in that, they recommended deploying up to 2.7 gigawatts of power, CCS and hydrogen capacity, plus 4 gigawatts of BECCS by 2030 to achieve a clean power system. They also noted that a system with flexible low carbon power would be the least cost and deliver lower systems costs than a strategy focused mostly on expanding renewables and flexibility. There are, of course, costs in, we have to balance demand and you have to have reliable, dispatchable demand. So, to say that, that how we're going to do that, and that's what the NESO have done in their modelling, and they looked at the options to do that. So if there are criticisms against that, then what are the alternative options of doing that? Because that is, in their view, the least cost option. There are, of course, costs involved in upgrading the grid and many other additional costs in how we provide that stable grid. So all of those costs have to be considered, and then looking at the embedded carbon and how we construct all of that as well is a question there. I think, have I covered all? Oh, cost. So in terms of what this government's pledge was, it is 21.7 billion over 25 years. So it's less than $1 billion a year. It's 0.8 billion. That's what the pledge is. That's what the commitment is. It's 21.7 over 25 years. And if you compare that to how we established the offshore wind industry and the commitments that were put there, it is significantly less. But it's not to say that it isn't a significant amount of money. Of course it is. But when you consider the costs that in the time period over which it's spanned, and also that most these projects are funded by the private sector upfront. These are upfront funded private sector projects, and the point at which that subsidy is then deployed is when the projects are operational, so 4 to 5 years down the line. I think one point, just coming back on a previous point in terms of delays in projects are, and I think this comes back to some of your points as well, Jennifer, that the UK government has spent a long time setting up a framework, regulatory framework, legislative framework to establish the industry, and it is within that the primary concern is industrial decarbonisation, but in terms of the funding is to make sure that that funding is spent sensibly, that there are checks and balances in place, and that is maximum value for money to the taxpayer, and the business models and the way in which that is being set up is how that is designed. The storage is very carefully. There are permits, licenses awarded to storage operators to make sure that that storage is monitored, verified, the CO2 is retained down there and is stored permanently. So a lot of that is why this has taken quite so long to get to where we are, and also there have been previous attempts to deploy CCUS in the UK, and this time, we are actually at the point now in the last year we've had 5 final investment decisions, and that's a significant amount when you look at when you look across the whole industry. We have made real progress in the last year, but this has been a long time in the making. So delays to projects is invariably, without pointing the finger, has been down to delays in the policy frameworks or in the funding frameworks to enable those decisions to move forward. A lot of projects have been waiting for that opportunity. And very lastly, in terms of moving away from subsidy, the government is very clear that it is, it is investing in this industry in the initial stages with a view to the industry becoming self-sustaining. They published a study, a vision, the CCUS vision, in back end of 2023. Is it 24? 23. December 2023, to set out the route to market and the vision for the industry. And so that's been a clear message to the industry, and the industry has been spending a lot of time and with government on how to develop those revenue streams, how to look at options for how this industry can become self-sustaining. And so there are already, we are seeing revenue streams from low carbon products. Low carbon cement there's a low carbon cement plant in Norway that has its order book full. There is a demand for this project, and that will bring a revenue stream into the industry to pay for that. There are also carbon removal credits which are being sold to the voluntary carbon market. There is a demand there, and that is also helping to pay. So there are examples of, and how the industry will move that way. I don't think it's in anyone's intention that this is an industry that just continues to be subsidised. But no industry, the beginning of offshore wind, the beginning of renewables, I worked at the beginning of solar PV. None of these industries just went from zero to nothing overnight. There has to be a scaling up, and there has to be time while those industries develop and then become self-sustaining in the longer term.
Thanks, Olivia. I'm quite conscious of time, and I would like to take some questions from the audience, but I don't know, Jen and Scott, whether there's any very quick reflections on what you've heard, or whether you're happy for me to go straight to questions and then...
If you don't mind, can I just ask Olivia a very quick question? So, I think somebody else mentioned reform. So I guess if you wanted to stop CCS, you could vote for reform. Yeah, I don't know. But you're thinking long term about your financial modelling. Is the political uncertainty in the UK, is that a risk factor?
I think, the other side of carbon capture is that it protects our industries in the longer term and enables them to decarbonise and have a future and transition. So without that, we have seen some industrial closures, and that's of interest to any political party. They want to keep jobs, they want to retain jobs, and they want to move forward.
The political consensus around climate and net zero seems to have gone now in the UK, I think. You would think the Conservatives now they're in opposition, they're much more net zero along with reform. So
yeah, but there are, and I guess what I'm saying in response to that is there are many drivers to carbon capture, protecting our industries, retaining them, giving them a future, enabling them to remain competitive. Is as much as a driver as it is in terms of reaching net zero, and so this enables them to do that.
sorry.
Yeah, no, it's fine. I'm going to open to questions, and I'll take them in rounds probably. Pick, do you want to take the go at the back there?
Button. Hi, I'm Sachin Sinha. I'm with Bumblebee Connect. We're a small consultancy focused on environment policy. It's been a very interesting discussion. Would the panel agree then, based on what I've heard, that CCUS is really only required to reach those hard-to-reach measures? And particularly for BECCS, from what I gather, there's no role really for it in the electricity system. We're just talking about those hard-to-reach parts of industry as opposed to actually electricity generation. Thank you.
Thanks. I'll take a couple more. This sorry, I'm making you run around. Just go by the aisle. Yeah.
Hi, I'm Greg Williams. I'm a town councillor in Shaftesbury. I wanted to ask a bit more about biomass, and it seems to be that the panel's view on biomass is very much dominated by one particular project. I wonder, Jamie and Josie, Simon in particular, you must have read the Committee on Climate Change 7th Carbon Budget, which has a lot of biomass, but all domestically sourced by 2050. So perhaps challenge you to say something positive about biomass and where you see the role for that, according to what the CCC thinks we're going to need a lot of it.
And just this last question at the front.
Thank you. Yeah. Simon Pearce, I'm a councillor in Greenwich, South East London. But in my sort of former life, I've worked in energy regulation and in trading technology as well, energy trading technology. I'm just curious in terms of question for Simon really about the upstream emissions for methane. Is there not a case for including methane then in kind of ETS schemes in order to kind of mitigate that? That side, because Olivia made the point that we do need a kind of a base load of some sort, could be nuclear, could be, for power generation, could be gas, but renewables aren't the whole answer because of the sort of volatility of the weather.
Thanks. I'm going to ask Jen to respond first, because I think that point about the sourcing for biomass is quite interesting, and I know you've done some work on that as well.
Yeah, I think there's a few points here that kind of speak across maybe a few of the questions.
Put the mic up.
Can you hear that? Yeah, a couple of points that maybe speak across a couple of those questions, actually. I think we still need to be really careful when we're talking about what type of CCS we're talking about, because fossil CCS or gas CCS can sometimes be used to mean two different things. There's electricity generation from gas with CCS, or there's using gas CCS to make hydrogen. And I think they sometimes get conflated. I'm not sure exactly which study this one refers to, or so perhaps we can chat afterwards. But I think so our analysis, going back to your question, Satyen, just to clarify, it says no new fossil CCS generation, electricity generation is needed. But we do need some flexibility in the system, and this speaks to your point, which is that there are some studies that say we can have a fully renewable electricity system. It's really difficult, and we do need to figure out how to have that flexibility. We don't call it base load so much anymore, but it's more about flexibility, right? So it's about how do we, when minute to minute and season to season, to match demand with supply. So if we're not going to do it with that kind of hydrogen, how do we do it? So I think this kind of speaks to this question, that the point that I said earlier, which is to really drive home, like, if we not take against, so that's just a light opinion, but if we really take a decision that some types of CCS are really against because of some of the very valid concerns that have been described. We really need to think about what else instead. And are they more desirable on technical, environmental, social, economic grounds, and really be thinking across all those factors. And that kind of throws it open to the need for a bit of a wider societal conversation. So on the biomass point that you asked about, Joe, is it a challenge to say something about positive about biomass? Yeah, it's funny when you're a kind of biomass researcher, people sometimes think you're fully pro biomass just because you talk about it a lot. And I'm definitely not. Look very much at some of the major concerns about it as well. So the CCC is saying major part should be domestic biomass at the moment. So some of that comes from concerns around the sourcing of biomass, particularly associated with DRAX, which you mentioned is dominates our conversation on biomass. Very valid concerns around the sourcing of that. So the Ofgem investigation, which has got lots of public opinion, a couple of years ago found that they weren't able to for a particular year, that company wasn't able to provide sufficient evidence about how they'd come to the judgment about that they were meeting the sustainability goals. And there have been lots of public attention on where that biomass is coming from in Canada and the States, whether it's causing deforestation. So with biomass, we really need to be looking across the whole supply chain. We do with any technology, but with biomass, it has this really challenging issue because it's very geographically diverse. We have this really long international supply chains, and we need to be considering the emissions and all environmental impacts associated with right from the production through to the harvesting and the storage and the processing, the transport, as well as the technological side, which applies to the CCS or power generation of any other technologies. And yeah, there are big concerns around that. However, we are pursuing it. We have pursued it for a reason. It potentially has a really important part to play in providing some of that flexibility in the power system, and with power and heat as well. So that is that's what's to say positive about biomass, I think, is that our models show that it does potentially have a really important role to play. So the question is, first of all, is our science good enough at estimating those full life cycle emissions? Are we good enough at understanding what direct or indirect land use change might be associated with producing that biomass at source? I think at the moment, a recent review by a colleague of mine, actually, Isabella Butnar, has shown that yes, probably, we're pretty good at that. We are at least trying to. Most studies are getting pretty good at estimating covering the full life cycle emissions, but there is big uncertainty over that sourcing aspect. But then, even if we're making improvements in that, then the second question is: are our systems, our monitoring, reporting, verification, and enforcement systems sufficiently robust and transparent to ensure that if there are problems, we spot them and we learn from them, and we make sure they're changing on a fairly rapid basis? And I think that's where the DRAX question story is right. It's right that we're putting a lot of scrutiny on that at the moment because we're in that learning process. We have one of these massive this big power station. We have some others as well, but that's a really strong learning process at the moment. Yeah. I think another potentially positive thing to say about biomass is that it's not DRAX or nothing. What we could be seeing is smaller systems which are much more linked to domestic biomass production, and I think that's potentially what some of the CCC scenarios are including, so more diversified but smaller scale industry in that sense. And there's another aspect to that, is that there are ways that we could potentially look for synergies in terms of production of biomass and other kind of environmental goals. So it might be that we could produce biomass domestically using sort of what we call second generation energy crops. So grasses, woody grasses that grow really fast and then you harvest them every few years on marginal land, or trees that grow fast and then you harvest them every few years. So short rotation coppicing or forestry on land that is marginal for some other reason. And it has potentially co-benefits for flood mitigation or soil or biodiversity. So that could work with other systems integrated with agriculture. So that's sort of that it's not Drax, expanding Drax or nothing. There are potentially other solutions. But I would say another thing is that if we are looking to rapidly and vastly increase domestic production, we really need to think about what else we're doing with land and have a kind of holistic look about land, because that puts another pressure on a relatively small island where we're also trying to increase food security and food supply and biodiversity and rewilding and building new houses and things. So kind of calls for a big look at that as well, which is happening in other quarters.
Thanks, Jennifer. And I'm interested to hear Simon's thoughts on the question about methane. The panel we had earlier, I think you were in the audience for, was looking at some of the big costs coming down the line for councils with ETS. So the thought about adding methane in fills me with horror and dread from a council budget perspective. Well, yes. But I mean, there are costs that have to be borne somewhere. But also, these systems need to be taking account of the latest science and doing what they can to kind of try and reduce those emissions in the systems. But Simon, to your thoughts on that?
Thank you. I'll try and be quick. So the interesting thought about methane, but the problem is it's leaking all over these vast supply chains, and there isn't good data on where it's coming from. There has to be an independent study conducted. The oil companies themselves claim it's far, far lower. And then when these independent studies look at it, it's high. So I don't think that's going to work. Biomass, I'm not going to say anything positive about burning stuff. We need to stop burning stuff. And I think the problem we're having as a country and as the whole world is that no government wants to be really frank that we are facing a really serious crisis, and there's a disconnect between what the scientists, the climate and nature scientists will tell you and what the public recognize, and they will tell you that we are hurtling towards a precipice, a lot less fast than we were under the last government, but we're still hurtling towards it, and we're still going to go over it. We need much more robust action, and the fact that we're avoiding telling people about it because it's not high on people's agenda. We haven't had a sort of a COVID-style briefing like we did with the pandemic. The fact that we're telling people, oh, you can just carry on with business as usual, is why we're going through all these contortions of trying to make things like biomass look workable and carbon capture. What we need to be doing is taking urgent action to cut our energy use. So this explosion of giant SUVs and private jets, and we've got to do something about it. It's 100% renewables is doable. Most people don't realize, but the science is quite clear that it's feasible. We can cope with night times and all that sort of thing. It's all about connecting countries together with much improved grid connections so that you can share wind from the Hebrides down to Spain and solar back up again, because it's always sunny or windy somewhere. And then you've got geothermal and tidal and wave and hydro, and it's been really carefully modelled. There was one study that looked at 145 countries, and they modelled the power data down to every 30 seconds for 3 years, and they've demonstrated it's doable. And UK would be with Europe, we'd be energy independent, we wouldn't be reliant on fossil dictators. Like, we're becoming really reliant on Trump now. And if these plans, these carbon capture plans, fossil fuel expansion plans go ahead, we're going to become really reliant on Trump. So we need to cut energy use. We need to go hell for leather for developing renewables. And I think we just need we need to be honest with ourselves that we can't sort this out on the side within business as usual. But if we do it, there are huge savings. So that study I told you about with the 3 years modeling, they showed that the total energy costs would be over 60% lower with a renewables-based energy system, because it's super efficient. A fossil fuel system is wasting 60% at least energy in heat, whereas renewable system is super efficient. Oh, and one more thing to say, and I'll shut up, is we are facing a nature crisis as well. So the idea that we're going to start planting vast areas of crops to feed these biomass monsters is nuts. It's threatening our food systems. Climate change is threatening simultaneous collapse of agriculture in our main breadbasket regions, and that's coming up soon. We need to and we're very food insecure here. We import so much of our food. We've got to stop burning stuff, and we've got to grow food and let nature recover. And we should be using our land for that, not for biomass, particularly when scientists say all the independent scientists, say that we can do it better with renewables.
Thanks, Simon. I'm very conscious of time. We're very much up against time, but I do want to ask the remaining panellists to just maybe share their reflections on the questions and closing remarks in as short a time as possible, please. Josie, shall I continue next?
Sure. Yeah, I mean, I agree with a lot of what you said and what you've been saying as well, Jen, at the end. Maybe we'll just end on kind of an additional stat on that to kind of complement what you were just saying, Simon. In response to your question about baseload, we found this year that with analysis that only 2% of days actually need that baseload backup power generation, because solar and wind are so complementary. You actually only have 2% of days where you have neither. And so I think the role of biomass or gas or nuclear is kind of overstated in the future energy system, especially if you have storage. So yeah, I'm also not going to say anything positive on biomass. Yeah, maybe I'll just leave it there. But yeah, thanks.
Thanks, Josie. Scott, do you want to share some final remarks?
This has been interesting. I think we all want the same thing. We're just looking at slightly different perspectives. I think, I said earlier, as an academic, I work in flood risk management, and when I started my career back in the 90s, I would say, if I'm optimistic, back then climate change was a possibility. Then it became something we knew was going to happen. Now it is happening. I think what's not happened over that time is we've not really equipped, communities right across the UK for that transition. And now all of a sudden it's in front of them, and they get worried about the cost of some of these things, and they get worried what it means for their lives. It was all easier when all they had to do was take their carrier bag to the shop rather than completely reusing them all the time, using the bag for life. But now they're faced with real decisions. And I think as a party and as a community, we have to discuss these things with people. So I do think it is about people changing their day-to-day lives, about using less power in the house, perhaps through insulating better. I think we've heard the case that carbon capture is for those really difficult, high CO2 outputters, that there is a case for it, and we do have to look seriously at it.
Olivia? Yeah, I mean, we are hurtling towards a precipice, and I think that's why we're here. So, Jimmy, it's not helpful to then criticise an industry that is working towards getting there, and we absolutely have to cut energy use, and we absolutely have to talk to the general public about how we're going to get there. In the meantime, we're all sat here, we all travelled here, we all have houses, we're all up for building new homes, hospitals, schools, infrastructure. We want to transport that food, and we need to do it tomorrow. So how are we going to do that? We don't have the systems in place to do any of those things without using concrete, steel, without using heavy industry that needs to decarbonize. And so I think it's that it has to be practical in terms of how we're going to get there. This is a transition, and we do need to have honest conversations with people, but at the same time we cannot just turn things off tomorrow, and we have to be pragmatic about how we're going to do that. And so I'm not sure about the 2%. I don't 2% of days. We can look at apps in terms of how often we look at the energy mix, and you can often see how much of that energy mix is provided with gas on a certain day. But I think none of this is about trying to say this is we shouldn't be making significant steps towards changing. Reducing our emissions. This is absolutely how we get there, and that's why these scenarios are all based around what is the optimum way of doing that, and how can we get there as fast as we can. And this is one of the tools in the box. And so I think to try and prevent it, you're still going to build all those pieces of infrastructure tomorrow, but if you're not going to do it without capturing the carbon, you're going to increase emissions.
Thanks. Jen, did you want to share any very quick 1 minute?
Yeah, just a call, I guess, to look at this kind of holistically. If we're not going to do CCS and BECCS, then what instead? So yes, there are scenarios that have very, very low levels of them, particularly for power. They are more expensive as far as I know. So we need to make sure we're comparing like for like in terms of costs, and not just talking about the cost of CCS, and not the difficulties and costs of the other scenarios. I think comparing like for like and looking holistically for that. And then again, really up for a big public engagement on what those other options do look like. My view is that we probably need to be doing it on all fronts. I think nobody is kind of, at least here, is feeling that we're not launching towards a precipice on emissions and energy and security and all sorts of factors. Nature crisis is massive for me. So really big public conversation alongside a steady industrial policy on that's supporting CCS for those smaller aspects that we're talking about, and thinking really carefully about what we mean in terms of reconfiguring transport and housing to make sure that we can lower energy demands, vastly increase efficiency, and facilitate those other sort of clean aspects as well.
Thank you. Thank you to all our panellists. I will get lots of trouble if I don't remind you to join SERA. There are some leaflets around with the barcode. You can scan them. It's really critical. We are a member-led organisation, the only Labour-affiliated environment organisation with membership, and we really rely on our members and subscriptions to be able to put on these events, do the work we're doing, and keep hosting these events and making sure these discussions happen. I've really enjoyed the panel this evening. I hope you all have as well. It's clear there's lots of challenges we face with the scale of transition that's needed, but I hope what we've heard this evening, I think it's been a really interesting dip into looking at the role and risks also of CCS, and I think Jen's note she ended on calling for a more holistic view of things is also really valid, and I hope it's been some food for thought for Scott to take back to Parliament and feed into Labour Party policy making as well. So thank you all for your time, and thanks to the panel for their contributions.